In the beginning, God created the heavens and the earth. With majestic simplicity, the ancient author of the opening chapter of Genesis thus differentiated his viewpoint not only from the creation myths of Israel's neighbors, but also effectively from modern pantheism, such as found in religions like Advaita Vedanta Hinduism and Taoism, from panentheism, whether of classical Neoplatonist vintage or 20th century Protestant theology, and from polytheism, ranging from ancient paganism to contemporary Mormonism. The biblical writers give us to understand that the universe had a temporal origin and thus imply creatio ex nihilo in the temporal sense, that God brought the universe into being without a material cause at some point in the finite past. Moreover, the Church Fathers, though heavily influenced by Greek thought, dug in their heels concerning the doctrine of creation, sturdily insisting on the temporal creation of the universe ex nihilo, in opposition to the prevailing Hellenistic doctrine of the eternity of matter, a tradition of robust argumentation against the past eternity of the world and in favor of creatio ex nihilo, issuing from the Alexandrian Christian theologian John Philoponus, who died around 580, continued for centuries in Islamic, Jewish, and Christian thought. In 1215, the Catholic Church promulgated temporal creatio ex nihilo as official church doctrine at the Fourth Lateran Council, declaring God to be the creator of all things, visible and invisible, who by his almighty power, from the beginning of time, has created both orders in the same way out of nothing. This remarkable declaration not only affirms that God created everything apart from himself without recourse to any material cause, but even that time itself had a beginning. The doctrine of creation is thus inherently bound up with temporal considerations and entails that God brought the universe into being at some point in the past without any antecedent or contemporaneous material cause. In today's paper, I leave aside the fascinating philosophical arguments raised by the doctrine of creatio ex nihilo, which I've sought to explicate elsewhere, in order to focus upon the relevance of contemporary science, in particular astrophysics, and still more specifically, physical cosmogony to creation ex nihilo. Two independently but closely interrelated lines of physical evidence are relevant to the doctrine of creation ex nihilo, namely the evidence from the expansion of the universe and the evidence from the thermodynamic properties of the universe. Due to time limitations, we shall consider only the evidence to the expansion of the universe. In Aristotelian physics, prime matter, of which all physical substances are composed, is, like God himself, eternal and uncreated. It underlies the eternal process of generation and corruption undergone by things in the sublunary realm. In its large-scale structure, the universe has remained unchanged from all eternity. Even with the demise of Aristotelian physics in the scientific revolution completed by Isaac Newton, the assumption of a static universe remained unchallenged. Although Newton himself believed that God had created the world, the universe described by his physics was, to all appearances, eternal. The assumption that the universe was never created was only further reinforced by Hermann Helmholtz's statement in the 19th century of the laws of the conservation of matter and energy. Since matter and energy can be neither created nor destroyed, there must have always been and will always be a universe. That is to say, the universe is temporally infinite in the past and the future. To be sure, there were already clues in pre-relativistic physics, like Olbers's paradox of why the night sky is dark rather than aflame with light if an infinity of stars has existed from eternity past, or like the second law of thermodynamics, which seemed to imply that the universe, if it has existed from eternity, ought to be moribund in a state of equilibrium, that there was something wrong with the prevailing assumption of an eternal static universe. But these niggling worries could not overturn what was everywhere taken for granted, that the universe as a whole has existed and will exist unchanged forever. Tremors of the impending earthquake, which would demolish the old cosmology, were first felt in 1917, when Albert Einstein made a cosmological application of his newly discovered gravitational theory, the general theory of relativity. Einstein assumed that the universe is homogeneous and isotropic, and that it exists in a steady state, with a constant mean mass density and a constant curvature of space. To his chagrin, however, he found that general relativity would not permit such a model of the universe unless he introduced into his gravitational field equations a certain fudge factor, lambda, in order to counterbalance the gravitational effect of matter and so ensure a static universe. Einstein's static universe was balanced on a razor's edge, however, and the least perturbation, even the transport of matter from one part of the universe to another, would cause the universe to either implode or to expand. By taking this feature of Einstein's model seriously, the Russian mathematician Alexander Friedmann and the Belgian astronomer Georges Lemaitre were able to formulate independently in the 1920s solutions to the field equations which predicted an expanding universe. The monumental significance of the Friedmann-Lemaitre model lay in its historization of the universe. As one commentator has remarked, up until this time, the idea of the expansion of the universe was absolutely beyond comprehension. Throughout all of human history, the universe was regarded as fixed and immutable, and the idea that it might actually be changing was inconceivable. But if the Friedmann-Lemaitre model were correct, the universe could no longer be adequately treated as a static entity, existing in effect timelessly. Rather, the universe has a history, and time will not be a matter of indifference for our investigation of the universe. In 1929, the American astronomer Edwin Hubble's measurements of the red shift in the optical spectra of light from distant galaxies, which was taken to indicate a universal recession of the light sources in the line of sight, provided a dramatic verification of the Friedmann-Lemaitre model. Incredibly, what Hubble had discovered was the isotropic expansion of the universe predicted by Friedmann and Lemaitre on the basis of Einstein's general theory of relativity. It was a veritable turning point in the history of science. Of all the great predictions that science has ever made over the centuries, exclaims John Wheeler, was there ever one greater than this? To predict, and to predict correctly, and to predict against all expectation a phenomenon so fantastic as the expansion of the universe. According to the Friedman-Lemaitre model, as time proceeds, the distances separating galactic masses become greater. It is important to understand that as a general relativistic theory, the model does not describe the expansion of the material content of the universe into a pre-existing, empty Newtonian space, but rather the expansion of space itself. The ideal particles of the cosmological fluid constituted by the matter and energy of the universe are conceived to be at rest with respect to space, but to recede progressively from one another as space itself expands or stretches, just as buttons glued to the surface of a balloon would recede from one another as the balloon inflates. As the universe expands, it becomes less and less dense. This has the astonishing implication that as one reverses the expansion and extrapolates back in time, the universe becomes progressively denser until one arrives at a state of infinite density at some point in the finite past. This state represents a singularity at which space-time curvature, along with temperature, pressure, and density, becomes infinite. It therefore constitutes an edge or boundary to space-time itself. Physicist P.C.W. Davies comments, if we extrapolate this prediction to its extreme, we reach a point when all distances in the universe have shrunk to zero. An initial cosmological singularity therefore forms a past temporal extremity to the universe. We cannot continue physical reasoning, or even the concept of space-time, through such an extremity. For this reason, most cosmologists think of the initial singularity as the beginning of the universe. On this view, the Big Bang represents the creation event, the creation not only of all the matter and energy in the universe, but also of space-time itself. The term Big Bang, originally a derisive expression coined by Fred Hoyle to characterize the beginning of the universe predicted by the Friedman-Lemaitre model, is thus potentially misleading, since the expansion cannot be visualized from the outside, there being no outside, just as there is no before with respect to the Big Bang. The standard Big Bang model, as the Friedman-Lemaitre model came to be called, thus describes a universe which is not eternal in the past, but which came into being a finite time ago. Moreover, and this deserves underscoring, the origin it posits is an absolute origin ex nihilo, for not only all matter and energy, but space and time themselves come into being at the initial cosmological singularity. As John Barrow and Frank Tipler emphasize, at this singularity, space and time came into existence. Literally, nothing existed before the singularity. So, if the universe originated at such a singularity, we would truly have a creation ex nihilo. On the standard model, the universe originates ex nihilo in the sense that at the initial singularity, it is true that there is no earlier space-time point, or it is false that something existed prior to the singularity. Although advances in astrophysical cosmogony have forced various revisions in the Standard Model, principally the addition of an early inflationary era and an accelerating expansion, nothing has called into question its fundamental prediction of the finitude of the past and the beginning of the universe. Indeed, the history of 20th century cosmogony has seen a parade of failed theories trying to avert the absolute beginning predicted by the Standard Model. These beginningless models have been repeatedly shown either to be physically untenable or to imply the very beginning of the universe which they sought to avoid. Meanwhile, a series of remarkable singularity theorems has increasingly tightened the loop around empirically tenable cosmogonic models by showing that under more and more generalized conditions, a beginning is inevitable. In 2003, Arvin Bord, Alan Guth, and Alexander Vilenkin were able to show that any universe, which is on average in a state of cosmic expansion throughout its history, cannot be infinite in the past, but must have a beginning. In 2012, Vilenkin showed that cosmogonic models which do not fall under this single condition fail on other grounds to avert the beginning of the universe. Vilenkin concluded there are no models at this time that provide a satisfactory model for a universe without a beginning. More recently, Vilenkin strengthened that conclusion. We have no viable models of an eternal universe. The Bord-Guth-Vilenkin theorem gives reason to believe that such models simply cannot be constructed. Cosmologist Sean Carroll, in an effort to subvert the implications of the Bord-Guth-Vilenkin theorem, has recently cited privately communicated remarks from Alan Guth to the effect that I don't know whether the universe had a beginning. I suspect that the universe didn't have a beginning. It's very likely eternal, but nobody knows. Carroll rightly asks, now how in the world can the author of the Bord-Guth-Vilenkin theorem say the universe is probably eternal? More aptly, how can one of its authors say that it is probably eternal and the other that it is probably not? Carroll assured his audience that the reason is that the theorem is only about classical descriptions of the universe, not about the universe itself. That would not, however, explain how Vilenkin could be so desperately mistaken about the theorem's implications. But now, new light has been shed on Guth's enigmatic remarks through correspondence with the philosopher Daniel Kame. There, Guth reveals that he favors models of the universe featuring a reversal of time's arrow at some point in the past, and that his remarks to Carroll had reference to such models. Such models do not fall under the Bord-Guth-Vilenkin theorem because they do not satisfy the single condition of that theorem, that the universe is on average in a state of cosmic expansion throughout its history. Thus, neither Guth nor Vilenkin is mistaken about the theorem's implications. Rather, Guth just advocates a model to which the theorem does not apply. Unfortunately, for hopefuls of a past eternal universe like Guth and Carroll, however, such time reversal models are highly unphysical and, even if successful, do not in fact avert the beginning of the universe, but rather imply it. For that time reversed expansion is in no sense in our past, but represents a universe sharing the same beginning point, but expanding in another direction. Vilenkin had already considered such models in his previous discussions and rejected them. That is why he said, and I quote, "All the evidence we have says that the universe had a beginning." The Born-Guth-Vilenkin theorem proves that classical space-time, under a single, very general condition, cannot be extended to past infinity, but must reach a boundary at some time in the finite past. Now, either there was something on the other side of that boundary or not. If not, then that boundary just is the beginning of the universe. If there was something on the other side, then it will be a non-classical region described by the yet-to-be-discovered theory of quantum gravity. In that case, Vilenkin says, it will be the beginning of the universe. For consider, if there is such a non-classical region, then it is not past eternal in the classical sense. But neither does it seem to exist literally, timelessly, akin to the way in which philosophers consider abstract objects to be timeless, or theologians take God to be timeless. For this region is supposed to have existed before the classical era, and the classical era is supposed to have emerged from it, which seems to posit a temporal relation between the quantum gravity era and the classical era. In any case, such a quantum state is not stable, and so would either produce the universe from eternity past or not at all. As Anthony Aguirre and John Kihayas argue, it is very difficult to devise a system, especially a quantum one, that does nothing forever, then evolves. A truly stationary or periodic quantum state, which would last forever, would never evolve, whereas one with any instability would not endure for indefinite time. Hence, the quantum gravity era would have to have itself a beginning in order to explain why it transitioned just some 14 billion years ago into classical time and space. Hence, whether at the boundary or at the quantum gravity regime, the universe began to exist. Davies raises the inevitable question: what caused the Big Bang? One might consider some supernatural force, some agency beyond space and time, as being responsible for the Big Bang. Or one might prefer to regard the Big Bang as an event without a cause. It seems to me that we don't have too much choice. Either something outside the physical world or an event without a cause. It might seem metaphysically absurd that the universe should come into being without a cause, and therefore a supernatural agency is to be preferred. But some scientists have contended that quantum physics can explain the origin of the universe from nothing. Unfortunately, some of these scientists have an outrageously naive grasp of language. The word nothing is a term of universal negation. It means not anything. So, for example, if I say, I had nothing for lunch today, I mean I did not have anything for lunch today. If you read an account of World War II, in which it says that nothing stopped the German advance from sweeping across Belgium, it means that the German advance was not stopped by anything. If a theologian tells you that God created the universe out of nothing, he means that God's creation of the universe was not out of anything. The word nothing, to repeat, is simply a term of universal negation, meaning not anything. There's a whole series of similar words of universal negation in English. Nobody means not anybody. None means not one. Nowhere means not anywhere. No place means not in any place. Now, because the word nothing is grammatically a pronoun, we can use it as the subject or direct object of a sentence. By taking these words not as terms of universal negation, but as words referring to something, we can generate all sorts of funny situations. If you say, I saw nobody in the hall, the wiseacre replies, yeah, he's been hanging around there a lot lately. If you say, I had nothing for lunch today, he says, really? How did it taste? These sorts of puns are as old as literature itself. In Homer's Odyssey, Odysseus introduces himself to the Cyclops as no man or nobody. One night, Odysseus puts out the Cyclops' eye. His fellow Cyclopses hear him screaming and yell to him, "What's the matter with you, making so much noise that we can't sleep?" The Cyclops answers, "Nobody is killing me, nobody is killing me." They reply, "Well, if nobody is attacking you, then you must be sick, and there's nothing we can do about it." In Euripides' version of the story, he composes a very funny dialogue. "Why are you crying out, Cyclops? Nobody has undone me." "Then there's no one hurting you after all." "Nobody is blinding me." "Then you're not blind. As blind as you, how could nobody have made you blind? You are mocking me. But where is this nobody?" "Nowhere, Cyclops." The use of words of negation like nothing, nobody, and no one as singular terms referring to something is a joke. How astonishing, then, to find that some physicists whose mother tongue is English have used these words precisely as singular terms of reference. For example, Lawrence Krauss has told us with a straight face there are a variety of forms of nothing, and they all have physical definitions. The laws of quantum mechanics tell us that nothing is unstable. 70% of the dominant stuff in the universe is nothing. There's nothing there, but it has energy. Nothing weighs something. Nothing is almost everything. All of these claims take the word nothing to be a singular term referring to something. For example, the quantum vacuum or quantum mechanical fields. These are physical realities and therefore clearly something. To call these realities nothing is at best misleading, guaranteed to confuse laypeople, and at worst, a deliberate misrepresentation of science. Such statements do not even begin to address, much less answer, the question why the universe exists rather than nothing. In his review of Krauss's book, A Universe from Nothing, David Albert, an eminent philosopher of quantum physics, explains, with respect to Krauss's first kind of nothing, vacuum states are particular arrangements of elementary physical stuff. The fact that some arrangements of fields happen to correspond to the existence of particles and some don't is not a whit more mysterious than the fact that some of the possible arrangements of my fingers happen to correspond to the existence of a fist, and some don't. And the fact that particles can pop in and out of existence over time as those fields rearrange themselves is not a whit more mysterious than the fact that fists can pop in and out of existence over time as my fingers rearrange themselves. And none of these poppings amounts to anything even remotely in the neighborhood of a creation from nothing. He concludes Krauss is dead wrong, and his religious and philosophical critics are absolutely right. Alex Vilenkin has a different proposal as to how the universe could come into being from literally nothing. In response to the claim of a supernatural agency, he says, regarding the Borde-Guth-Vilenkin theorem and its relation to God, I think the theorem implies the existence of a rather special state at the past boundary of classical space-time. Some mechanism is required to impose that state. Craig wants this mechanism to be God, but I think quantum cosmology could do just as well. Just what does Vilenkin have in mind here? Well, he explains, modern physics can describe the emergence of the universe as a physical process that does not require a cause. Nothing can be created from nothing, says Lucretius, if only because the conservation of energy makes it impossible to create nothing from nothing. And I think that's a misprint. I think he meant to say that the conservation laws make it impossible to create something from nothing. Vilenkin goes on to say there is a loophole in this reasoning. The energy of the gravitational field is negative. It is conceivable that this negative energy could compensate for the positive energy of matter, making the total energy of the cosmos equal to zero. In fact, this is precisely what happens in a closed universe, in which space closes on itself like the surface of a sphere. It follows from the laws of general relativity that the total energy of such a universe is necessarily equal to zero. If all the conserved numbers of a closed universe are equal to zero, then there is nothing to prevent such a universe from being spontaneously created out of nothing. And according to quantum mechanics, any process which is not strictly forbidden by the conservation laws will happen with some probability. What causes the universe to pop out of nothing? No cause is needed. I think this is a terrible argument. Grant the supposition that the positive energy associated with matter is exactly counterbalanced by the negative energy associated with gravity, so that on balance, the total energy is zero. Vilenkin's key move comes with the claim that in such a case, there is nothing to prevent such a universe from being spontaneously created out of nothing. Now, this claim is a triviality. Necessarily, if there is nothing, then there is nothing to prevent the universe from coming into being. By the same token, if there is nothing, then there is nothing to permit the universe to come into being. If there were anything to prevent or permit the universe's coming into being, then there would be something, not nothing. If there is nothing, then there is nothing, period. The absence of anything to prevent the universe's coming into being does not, however, imply the metaphysical possibility of the universe's coming into being from nothing. To illustrate, if there were nothing, then there would be nothing to prevent God's coming into being from nothing. But that does not entail that such a thing is metaphysically possible. It is metaphysically impossible for God to come into being, even if there were nothing to prevent it because nothing existed. Vilenkin, however, infers that no cause is needed for the universe's coming into being because the conservation laws would not prevent it. And, according to quantum mechanics, any process which is not strictly forbidden by the conservation laws will happen. The argument assumes that if there were nothing, then both the conservation laws and quantum physical laws would still hold. This is far from obvious, however, since in the absence of anything at all, it's not clear that the laws governing our universe would hold. In any case, why think that given the laws of quantum mechanics, anything not strictly forbidden by the conservation laws will happen? The conservation laws do not strictly forbid God's sending everyone to heaven, but that hardly gives grounds for optimism. Neither do they strictly forbid his sending everyone to hell, in which case both outcomes will occur, which is logically impossible as they are logically contrary universal generalizations. The point can be made non-theologically as well. The conservation laws do not strictly forbid something's coming into existence, but neither do they strictly forbid nothing's coming into existence. But both cannot happen. It is logically absurd to think that because something is not forbidden by the conservation laws, it will therefore happen. Finally, Vilenkin's inference that because the positive and negative energy in the universe sum to zero, therefore no cause of the universe's coming into being is needed, is hard to take seriously. This is like saying that if your debts balance your assets, then your net worth is zero, and so there is no cause of your financial situation. Vilenkin would not, I hope, agree with Peter Atkins that because the positive and negative energy of the universe sum to zero, therefore nothing exists now, and so nothing did indeed come from nothing. For as Descartes taught us, I, at least, obviously exist, and so something exists. Christopher Isham, Britain's premier quantum cosmologist, rightly points out that there still needs to be ontic seeding to create the positive and negative energy in the first place, even if on balance its sum is naught. Even if one were to concede the absence of a material cause of the universe, the need of an efficient cause is patent. We thus have two independent lines of scientific evidence in support of the beginning of the universe. First, as we have seen today, the expansion of the universe implies that the universe had a beginning. Second, thermodynamics also shows that the universe began to exist. Because these lines of evidence are independent and mutually reinforcing, the confirmation they supply for a beginning of the universe is all the stronger. Of course, as with all scientific results, this evidence is provisional. As Sean Carroll reminds us, science isn't in the business of proving things. Rather, science judges the merits of competing models in terms of their simplicity, clarity, comprehensiveness, and fit to the data. Unsuccessful theories are never disproven, as we can always concoct elaborate schemes to save the phenomena. They just fade away as better theories gain acceptance. Science cannot force us to accept the beginning of the universe. One can always concoct elaborate schemes to explain away the evidence. But those schemes have not fared well in displaying the aforementioned scientific virtues. Given the metaphysical impossibility of the universe's coming into being from nothing, belief in a supernatural creator is eminently reasonable. At the very least, we can say confidently that the person who believes in the doctrine of creatio ex nihilo will not find himself contradicted by the empirical evidence of contemporary cosmology, but, on the contrary, fully in line with it.